This is part 5 of a review of exponential and logarithmic functions. If you have not seen part 4, you can either click the link that appears in the upper right hand corner or find the link in the description. On the AP exam, there will be 4 free response questions. In this video, we will work through a couple word problems similar to the ones that you might find on FRQ 2. This is AP Precalculus topic 2.9 through 2.15. If you appreciate this content, please give it a like. 33. Starting in 2018, a biologist studied the population of largemouth bass in a particular lake over several years. In 2019, t equals 1, there were 430 largemouth bass in the lake. In 2023, t equals 5, there were 715 largemouth bass in the lake. The number of largemouth bass in the lake can be modeled by the function L, given by L of t equals a plus b natural log t, where L of t is the number of largemouth bass in the lake during year t, and t is the number of years since 2018. A. Part 1. Use the given data to write 2 equations that can be used to find the values for constants a and b in the expression for L of t. Every input-output pair can be used to write an equation. For example, if we plug in an input value of 1, it should equal an output value of 430. So that gives us the first equation, a plus b natural log 1 is equal to 430. If we plug in an input value of 5, it should equal an output value of 715. So that is the second equation. A plus b natural log of 5 is equal to 715. A. Part 2. Find the values of a and b. There are 2 ways to find the values of a and b. Method 1 is to do it mostly by hand, and then method 2 is to use your graphing calculator to find a regression model. Method 2 only works if the model they gave you is exactly a plus b natural log t. We were lucky this time, and method 2 would work, and it would be very fast. However, I need to show you both methods because they often will not give you a model in this form. It's common to get something like a plus b natural log t plus 1. And I need you to understand that if that happens, if it's not exactly a plus b natural log t, the regression model will not work. This is the only model that your calculator has for logarithms. So first I'm going to show you how to find a and b mostly by hand, and then afterwards I'll show you how to find a and b using a regression model on the calculator. So, looking at the first equation, natural log of 1 is 0. Hopefully you have memorized that. So this term is really 0. So the blue equation becomes a equals 430, and we have the value of a. Now we just need to use this to find the value of b. Switching over to the red equation, but substituting 430 in for a, gives us 430 plus b natural log 5 is equal to 715. We just need to isolate b. Let's start by subtracting 430 from both sides. 285. Now we can isolate b by dividing both sides by natural log 5. So we get b is equal to 285 divided by natural log 5. Let's put this in the calculator to get a decimal approximation. I recommend using 4 decimal places and never rounding. So that's it. We have found the values of a and b in this regression model. We are going to need this regression model in Y1 to help us answer the rest of these questions. So if we were going to go on from here without using log regression, then we would need to store these values into the letters A and B on the calculator so we don't lose any accuracy. So we just found B. Let's store this value into letter B by hitting store and then alpha B. This is not necessary to store the 430 as A, but let's do that as well just to be consistent. So we can just type 430 and then store that as alpha A. Now we could get the regression model, well, not the regression model, but the model L of t into y1 by simply typing in A plus B natural log t. Well, natural log x. And we could go on to use y1 to answer the other questions. But now I want to show you how to quickly use the regression capabilities of your calculator to accomplish the same thing. So here are the input-output pairs in table form. Let's enter this table into the calculator. You hit stat and then enter. And then you type in the input values as L1 and the output values as L2 like this. Then you hit stat and switch over to the calc menu, and we are going to choose natural log regression. So that's option 9, and you can just hit the 9 key. Always have your calculator store the regression model as y1 by coming here and hitting alpha, trace, enter. Hit enter a couple more times and it will calculate the regression model. And there it is. So there's the A value and B value, exactly the same as what we found before. And the regression model has been entered as y1 with all of the many decimals. B part 1. Use the given data to find the average rate of change of the number of largemouth bass in the lake in fish per year from t equals 1 to t equals 5 years. Express your answer as a decimal approximation. Show the computations that lead to your answer. The model L of t gives the number of largemouth bass. On the interval from 1 to 5, the average rate of change of L of t is given by L at 5 minus L at 1 divided by 5 minus 1. L at 5 is 715 and L at 1 is 430. So now we have this. Let's use the calculator to find a decimal approximation. So I got this fraction. We need a decimal approximation. So we can just retype it and do 285 divided by 4. And that will give you the decimal form, 71.25. And don't forget the units, which are fish per year. B part 2. Interpret the meaning of your answer from part 1 in the context of the problem. Start by stating the meaning of the function that we are using. L of t is the number of largemouth bass in the lake. Next you say by how much this value is increasing or decreasing. Increasing if positive and decreasing if negative. Be sure to include the units here. Finally, to earn the point, you must mention the interval on which the average rate of change was calculated. Let's put it all together. The number of largemouth bass in the lake is increasing by 71.25 fish per year on average from t equals 1 to t equals 5 years since 2018. B part 3. Consider the average rates of change of L from t equals 5 to t equals p years, where p is greater than 5. Are these average rates of change less than or greater than the average rate of change from t equals 1 to t equals 5 years found in part 1? Explain your reasoning. Start by writing down the model with A and B filled in. So L of t is equal to 430 plus 177.0804 natural log t. The key to this question is the graph of L of t. We have memorized that the graph of the parent function natural log t looks like this. The graph of L is a vertical translation of the parent function and a vertical dilation. Neither of those transformations is going to change the overall look of the graph. So L of t still looks like this. And what matters is that this is concave down, which means that the rates of change are decreasing. So start out by saying this. L of t is equal to this expression, which is always concave down. So the rates of change are decreasing. Therefore, the average rate of change from t equals 5 to t equals p years will be less than the average rate of change from t equals 1 to t equals 5 years. Number 34. The table above gives selected values for the life expectancy in years and income in thousands per year for individuals around the world. Part A. The data in the table can be modeled by the function L of x equals a plus b natural log x, where x is the individual income in thousands per year, and L is the predicted life expectancy in years. Find the equation L of x using the regression features of your graphing calculator. Hit Stat Enter, and enter the input values in L1 and the output values in L2. Next, hit Stat and switch over to the Calc menu and choose option 9 for natural log regression. Always go down to this line and tell the calculator to store your regression model in Y1 by hitting Alpha, Trace, Enter. Now hit Enter 2 more times to calculate the model. And there it is. Just fill in the value for A and B here and here. There's your answer to Part A. Part B. In 2009, the United States had a per-person income of $41,256.10 and a life expectancy of 79.43 years. What is the residual of this data using the model found in Part A? The residual value is the actual value minus the predicted value. In this case, the actual value is the life expectancy of 79.43 years. The predicted value will be the value of the model at this input. However, the input has to be in thousands. So 41,256.10 is the same thing as 41.2561 thousand. So let's just evaluate this in the calculator. We stored this regression model in Y1. So pull up Y1 by hitting Alpha, Trace, Enter. We just need to evaluate this by using parentheses and typing in 41.2561. So this is the predicted life expectancy. So now we need to just subtract 79.43 minus this predicted value. Do not use a rounded value. One way to do this is to type in your 79.43 minus, but then if you go up and highlight this number and hit Enter, it appears right here with all of the decimals. So there's the answer, negative 1.6881. And the units would be in years. Another way to do the subtraction without losing any accuracy is to store this value in a letter on the calculator. So we could have hit store and, for example, alpha C. Then we could do 79.43 minus alpha C. So that's another way to do it. Part C. A given country has an average income of $43,500. According to the model found in Part A, what is the average life expectancy of an individual from this country? As we did right here, we need to move this decimal 3 times to the left to convert it from dollars into thousands. So this number is the same thing as 43.5 thousand. And we just need to evaluate L at 43.5. Of course, we stored the model as y1, so let's evaluate y1 by hitting alpha, trace enter, and then in parentheses goes the 43.5. So this is the answer to part C, 81.4641. Don't forget the units. Number 35. The function p is given by p of x equals 2 to the x squared minus 4 times 2 to the x. Find all values in the domain of p that yield an output value of 12. We need to set p of x equal to 12 and solve. It will be a little bit easier to see how to solve this problem if we first do something called u substitution. Notice that we have this common factor of 2 to the x in the first term and in the second term. So let's let u equal the 2 to the x power. If we do this u substitution, the equation becomes u squared minus 4u is equal to 12. Suddenly, this doesn't look so complicated. We need to get 0 on one side. So let's subtract 12 from both sides, and we get u squared minus 4u minus 12 is equal to 0. This trinomial is probably factorable. U squared factors as u times u. 12 can factor as 3 times 4, or 2 times 6, or 1 times 12. Let's go with 2 times 6 because we need a middle of negative 4, and inner plus outer gives us the middle. If we have an inner of positive 2u and an outer of negative 6u, that will give us a middle of negative 4. Setting each factor equal to 0 and solving gives us u is equal to negative 2 and u is equal to positive 6. Now we can substitute 2 to the x power back in for u, and we get 2 to the x power is equal to negative 2, and 2 to the x power is equal to 6. The first little equation has no solution. There is no power that you can raise 2 to that will give you a negative number. So this has no solution. We can disregard this. Let me just spend one more moment on that. If I try to raise 2, for example, to the negative 1 power, maybe that'll turn it into a negative 2. But raising 2 to the negative 1 power doesn't give you a negative 2. This drops you down to the denominator. So this would just be 1/2, not negative 2. So this is a common situation that I need you to watch out for. If you have a positive number and you're trying to raise it to some power, there is no power that will turn a positive number into a negative number. So immediately, no solution. We can solve the second small equation. We can make the 2 go away by taking the log base 2 of both sides of this equation. On the left side, the log base 2 and the base 2 cancel each other out. So that leaves us with x is equal to the log base 2 of 6. And there's nothing we can do with this, so this is the final answer. When you do the u substitution, you have to actually show this step right here. Write let u equal 2 to the x power. You can't just start using a new variable without defining it first. Number 36. As part of a training program, Stacy began working out in an attempt to lower the amount of time it took her to run 1 mile. Initially, t equals 0, it took Stacy 570 seconds to run 1 mile. At the end of each week during the training program, Stacy would run 1 mile and record her time. After 4 weeks, t equals 4, Stacy's time to run 1 mile was 465 seconds. Stacy's time to run 1 mile can be modeled by function m, given by m of t equals a plus b natural log t plus 1, where m of t is Stacy's time in seconds for week t, and t is the number of weeks since her initial run. A Part 1. Use the given data to write two equations that can be used to find the values for constants a and b in the expression for m of t. Each input-output pair can be plugged into the model to write an equation. So, when the input is 0, the output should equal 570. This gives us the equation a plus b natural log of 0 plus 1 is equal to 570. Similarly, if we plug in an input value of 4, it should equal the output value of 465. So that gives us the second equation, which is a plus b natural log 4 plus 1 is equal to 465. A Part 2. Find the values of a and b. Notice that we cannot use a regression model to find a and b because this is natural log t plus 1, not just natural log t. So we a little bit have to do it by hand. But it's not so bad. Let's start with the blue equation. Ignoring the 0, we have a plus b times the natural log of 1. And we know that the natural log of 1 is 0. So that makes this whole term 0, and we are left with just a is equal to 570. So we're halfway done already. We found a, we just need to find b. So let's switch over to the red equation, but we now know that a is 570. So the red equation becomes 570 plus b natural log 5 is equal to 465. We need to solve for b, so let's subtract 570 from both sides. Now we have b times the natural log of 5 is equal to negative 105. We can isolate b by dividing both sides by natural log 5. Let's type this into the calculator so we can get a decimal approximation. Negative 65.2401. Use 4 decimal places and don't try to round. So that's it. We found the values of a and b. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.